Welcome to class of physics. In previous lectures we have studied about conservation of linear momentum and angular momentum. So now we are going to study about concept of work, power and energy in terms of line integrals. Let's study one by one. First one is work. Show the definition of work. Work is said to be done by a force when the point of application of force is displaced. Work done is measured by the product of force applied and the displacement of the point of application of the force in the direction of force. Simple. Here work means a force is doing work on a point. So that point should be displaced due to the application of the force. Suppose there is an object is there. Now this object is influenced by some kind of force. Now this object is going to displace. Now due to this displacement and the force, the work is said to be done. Only when the point of application of force is displaced an object, then we say that the work has done. And work done is measured by the product of force applied and the displacement. Here work can be calculated or measured by the product of force and the displacement, not the distance, the product of force and the displacement. F is force, we take S as displacement, then the work done is given by W is equal to F dot S. Okay. Sure, S is the displacement of the body in the direction of constant force F. Then work done is F dot S. It is dot product. For that, displacement S takes place in the direction making an angle theta with the direction of constant force F. The work done is given by W equal to F cos theta. Suppose the force is in these directions, the displacement is in these directions, then there is an angle between these two. So then work done can be written as W equal to F cos theta. Okay. Here force is vector quantity, displacement is also vector quantity, but the operation is here dot product, or we call this as scalar product, so that this work done W is treated as scalar quantity. Okay. So that work is scalar quantity and measured in joule. Unit of work is joule. So now work in terms of line integrals. Okay. So the general expression of work is F dot S cos theta. Now work in terms of line integral. Let a particle of mass m acted upon by a force F. Due to this, set into motion, not necessarily in the direction of force. Its actual path depends upon its initial velocity and the magnitude of the applied force. Now there is an object of mass m is there. A force F is acting on this. Then due to this force, this object is set into motions. The direction of the motion of this object is not necessarily in the direction of force. Okay. There is no necessary in the direction of force, but its actual path depends upon these two factors. One is initial velocity and magnitude of the force applied. Keep in mind, not necessarily in the direction of force, but it is also depends upon its initial velocity and the magnitude of the force applied. Let's do a simple expression. Let its path be along curve C joining the point A and B. So here there is an object is there. This is under the motion. Then the path of this motion is curved. So from A to B. So this is the path of the object. In that I am going to consider 2 points A and B. Okay. A and B is the initial and final position of the object. To determine the work done by the displacing the particle from A to B. Okay. Now we have to find the how much work has been done for the displacement of the object from A to B. So that consider a point P and P prime two neighboring points. We can't find the whole work at a time. First we have to find a work done for a certain displacement, for a small displacement, then adding up all that kind of work, then we will get the total work. Okay, in other words, we can integrate that small work, then we will get the total work done. For that, considering two neighboring points P and P prime such that their position vectors are r and r plus dr. Okay, so here r is the position vector of point P from the origin and r plus dr is the position vector of object at P prime from the origin. Okay. Now P prime gives delta r, or you can take it as dr. Okay, so which one? P prime, so this is delta r. Okay, or ds if you prefer to work in terms of length of the curve, and work done is given by dw equal to f dot ds. Okay, here in two ways we can find. One is using this position vector, or you can take this displacement. Okay, so here in terms of position vector, we have to consider these quantities and delta r. In terms of length of the path, then we can take ds. Okay, so ds is displacement, so this is ds. So the total work done by the force is displacing the particle during the whole length of the curve from A to B, that is w is given by the relation w equal to f dot dr. So here the integral is there, taking limits a and b. So a means from initial to final. Then in terms of line integrals, this expression can be written as f dot ds. Okay, a to b, integral of a to b. Then this is the dot product. So if it makes certain angle theta, then that work done can be written as f ds cos theta, or f cos theta into ds. Okay, so finally the work done in terms of line integral is integral of f cos theta into ds from a to b. These two are the limits. Okay, so this expression gives work done in terms of integrals. Here theta is the angle that the direction of the force makes with tangent to the curve at point. Okay. Here theta is what? It is the angle made by the direction of the force with the tangent of the curve at point. Okay. At this curve there is a tangent is there. Okay. So here, so this is the tangent. Sorry. This is the tangent. To this tangent, the direction of the force makes an angle theta. So that this f cos theta, the tangential component of the force. For that we call this f cos theta as tangential component of force along the curve at point P. Such an integral evaluated along the path of the particle is called line integral of the force F. Okay, so this component that we call as line integral of the force, or tangential component of the force. Okay, so next, power. Work is complete. Next comes to power. Okay, power means it is defined as a rate of doing work and is denoted by P or A. So power means what? It is a rate of doing work. In which rate the work has to be done. Okay, so this part is important. Power is rate of doing work. Since f dot dr is the work done by the force in moving the particle from P to P prime. Okay. Just take it as a previous diagram and as an example. F dot dr is the work done by the force in moving the particle from P to P prime in time interval of dt. So dt is what? The small time interval to move the particle from P to P prime. Then power is given by F into dr by dt. Okay. So here the definition is what? It is rate of doing work. Okay. So rate of doing work means we have to differentiate whatever the work is there, that is with respect to time. Okay. So then it becomes d by dt. So that power can written as F to dr by dt. Then what is dr by dt? Dr is position vector or change in position vector. Then its first derivative with respect to time will gives velocity. For that, power equal to what? F dot phi. Okay. So this F is force and P is velocity. This dot product of force and velocity, that will give power. P is instantaneous value of velocity acquired by the particle. From the above equation, we can write work as P dot dt. Okay. So from this equation, we can write work as P dot dt. Okay. So unit of power is watt, unit of work is joule, unit of power is watt. Okay. So this can be written as or represented by W. Next, energy. Energy means the energy of the particle is its capacity to do the work. Okay. So energy means capacity to do the work. And measured by the amount of work it is capable of doing in virtue of. Okay. And then this energy is measured by the amount of work, okay, it is capable of doing in virtue of two are there. One is its motion and the one is its position or conditions. Okay. That means energy is measured by the amount of work it is capable of doing in virtue of its position its motion and its position or conditions. If the measured energy is capable or the measured energy is virtue of its motion, then that energy equal to as kinetic energy. Okay. If the measured energy is virtue of its position or condition, then that equal to as potential energy. It is represented by U, and unit of energy is joule. Keep in mind, unit of work is what? It is joule. Unit of power is watt, and unit of energy is also joule. Okay. These two are having same units, and power unit is watt. So this is all about work, power and energy. Next class we are going to study two important derivations. One is conservation of energy and the other one is work energy theorem. Okay. Thank you.